Good evening, students. Now, once again, revision part, Unit 5, Diagonalization. Right, this is your syllabus. Diagonalization. Next, one problem based on that one. Diagonalization theorem is important. It's theory based on this definition only. A matrix A is said to be diagonalizable if it can be expressed as or factorized as A is equal to P inverse, or you can write A is equal to P inverse dP, right, where P is an invertible matrix, D is a diagonal matrix, right? And this is the diagonalization theorem that is there in your notebook. Please go through that one. It is a very important concept, important theorem also, right? Based on this theorem, number of problems will come, right? Next, diagonal matrix. Next one, problem solution. Next, an n by n matrix with the n distinct eigenvalues is always diagonalizable, right? This theorem also very important one. It's very easy one, right? Next, these are the problems. Okay, now first of all we are going to discuss about the first part, that is diagonalizable, right? Diagonalizable means a matrix A is a given matrix, right? Now this is matrix is said to be diagonalizable. If it can be factorized as P into D into P inverse. What is P? P is an invertible matrix. Invertible matrix means inverse of a matrix exists, then the matrix is said to be invertible. If inverse of a matrix does not exist, then it is not invertible. What is D? D is a diagonal matrix, right? Now this definition is very important. A matrix, whatever it may be the matrix, whatever it may be the order, it may be 2 by 2 or 3 by 3 or n by n matrix. This matrix is said to be diagonalizable if it can be factorized as A is equal to P inverse. Right, now this one also there is one application from here. If you multiply both sides post multiplying by P, what you will get here? AP is equal to PD, right? If AP is equal to PD also, then A is said to be diagonalizable. If the product of A and P we have to find out, and if the product of P and D also we have to find out. If they are equal, the given matrix is said to be diagonalizable, right? Now see, there is one problem in our exercise, first one. In exercise 1 and 2, let A is equal to P inverse and then compute A power 4. Right? First problem is here A is equal, P is given as, P is what? 5, 7, 2, 3, and D is also given 2, 0, 0, 1. Right? See, this problem we are going to discuss. Now exercise 1 and 2, let A is equal to P inverse and compute A power 4. Right? A is equal to P inverse means what? A is diagonalizable. Right? See here, given that A is equal to P inverse, that means A is diagonalizable. Right? A is diagonalizable. Now what is our aim? Our aim is to find A power 4 is equal to question mark. We know that A is equal to P inverse. A power 4 is what? P power 4 P inverse only. Sir, how sir means? See here in the rough work. Now A is equal to P inverse, no? A into A is nothing but what? A square, right? Now what is A? P inverse. Another A is P inverse, right? See here, P into D, P inverse into P is I, remaining is D, P inverse. See here, P, D into I is D, where I is a unit matrix, no? Again D here, P inverse. P D square P inverse. D into D is D square, no? Here A square is equal to P D square P inverse. Similarly, A cube is equal to P D cube P inverse. Okay, that is the formula. Now we need to compute A power 4, no? Right. First of all, P is there. We know P value, and we need to find a D power 4 and also P inverse. First of all, I am finding D power 4. D power 4 is nothing but 2 power 4, 0, 1 power 4. That's it. Since D is a diagonal matrix, D square is nothing but 2 square, 0 square, 0 square, 1 square. D cube is nothing but 2 cube, 0 cube, 0 cube, 1 cube. D power 4 is nothing but 2 power 4, 0 power 4, 0 power 4, 1 power 4. Right? No. There is this problem is there in our first page, last unit, first page. If you want, you can refer that one. Now see here. Now 2 power 4 is 2 into 2 into 2 into 2 4 times. 2 to the 4, 4 to the 8, 8 to the 16. 0, 0, 1 power 4 is 1. We got D power 4, right? Next we need to find P inverse. What is P inverse formula? Inverse of a matrix 1 by AD minus BC, D minus B minus C A. Suppose if P is equal to A, B, C, D, then we have to write like this. Okay? Now we know P. What is P? 5, 7, 2, 3. 5, 7, 2, 3 means P inverse is equal to 5 into 3 minus 7 into 2, right? By D. D comes first. Here D minus 7 minus 2, 5. Now simplify this one. 15 minus 14, 3 minus 7 minus 2, 5. Again 15 minus 14 is 1, 3 minus 7 minus 2, 5. 1 by 1 is 1, 1 into is equal to this one. 3 minus 7 minus 2, 5. We know P inverse, right? See, here only I am doing, just concentrate please. Now, therefore A power 4 is what? P D power 4 P inverse. This implies A power 4 is equal. What is P here? 5, 7, 2, 3. D power 4 we know just now. What is that? D power 4 is 16, 0, 0, 1. Into P inverse also we know. That is 3 minus 7 minus 2, 5. We have to multiply these three matrices one by one. First of all, I am going to multiply these two. Right? Now, A power 4 is equal to this multiplication, this row and this column, no? 5 into 16 plus 7 into 0. Next, 5 into 0 plus 7 into 1. This is plus here, this is a formula. Now this row into first column. 2 into 16 plus 3 into 0. Next, 2 into 0 plus 3 into 1. I am multiplying these two and the remaining matrix is same here. Now, there is no space, that's why I am writing. 15 into 16, 5, 6 are 30, 80. 7 into 0 is 0. 0, this is minus 7 no here, right? Oh, sorry, this is this one, no? First we are multiplying. I am getting 7. 2 16s are 32. This one is 0. Here I am getting 3. Into this matrix I have to write, no? See. 3 minus 7 minus 2, 5. Multiply these two. 8 into 3 plus 7 into minus 2. First one I am directly multiplying. Now see, 8 into 3 is 8 into 3, 240 minus 14. 8 into minus 7. 8 into minus 7 is minus 56. 560, no? Next, 7 into 5 plus 35. Next, 32 into 3. 32 into 3 2s are 6, 3 3s are 9. Next, 3 2s are minus 6. Okay. Now, 32 into minus 7. 14, 22. Minus 224. 3 5s are 15. Now, simplify this one. 240 minus 14. 10 minus 4 is 6. 226. First one. Next. 35 minus 525. 0 minus 5 is 5. Next 5 minus 3 is 2. Right, okay. Now here 90 and minus 224 plus 15. Right. Now 15 ante how much? 4, this is the 20, 11, 209, no? 209 plus, right, minus 209. 15 and 14, 1, 24, right. Now this answer is called A4. Therefore, A4 is equal to this much. Simply what we have to do, this is the procedure. A is diagonalizable, means A can be written as PDP inverse. Now where P is an invertible matrix, D is a diagonal matrix. Now P is given, D is given, find A4. A is not given here, but it can be written as A is equal to PD, P inverse. Using P we have to find P inverse. Using D we can find D power 4. Since A is equal to this one, A power 4 is equal to this one. Suppose if you want to find A power 10, then it will be D into T power 10 into P inverse only for any matrix if it is diagonalizable, right? Now this is first page. Second page. Now see here, rest of the problems are same. Here find, now this one, fifth one is given as, see, fifth one is given. What is the fifth one here? The problem is given 2, 2, 1 and 1, 3, 1, 1, 2, 2 is equal to, clearly given as 1, 1, 1, 1, 0, minus 1, 2, minus 1, 0 into, now 5, 0, 0, 0, 1, 0, 0, 0, 1 into 1 by 4, 1 by 2, 1 by 4, right? Next one is 1 by 4, 1 by 2 minus 3 by 4, 1 by 4 minus 1 by 2, 1 by 4, right? This problem we are going to discuss. Now it is in the form of, see, PDP inverse. Now what we have to find out, use diagonalization theorem, find the eigenvalues of A and an eigenbasis for each eigenspace, that we have to find out. See, here this matrix is A, which can be written as PDP inverse, right? PDP inverse. Now we need to find first of all eigenvalues. Eigenvalues are nothing but, see, in a diagonal matrix, in a D, the elements in the principal diagonal, elements in the principal diagonal is called, are called eigenvalues. See, what are the eigenvalues here? These are the main diagonal, no, principal diagonal. These elements are the eigenvalues in D, right? Now see, therefore eigenvalues of A is equal to what? You have to write 5, 1, 1. Find the eigenvalues means this one. Sir, how to find it directly means, you can know, you can find out A minus lambda I is equal to 0. From here we have to find a characteristic equation, then you will get eigenvalues. We will discuss this type of problems later. But now here in P, diagonalization problems, P is an invertible matrix, D the diagonal matrix whose entries and the principal diagonal entries are nothing but eigenvalues of A. Right? Remember this one. See, next one, eigenvalues we got. Next we need to find what? Basis for eigenspace. Basis for eigenspace is nothing but, see, the column elements of P. The column elements of P are nothing but, see, for lambda is equal to 5, the eigenvector of A is this one, 1, 1, 1, first column, right? Similarly, for lambda is equal to minus 1, corresponding to this eigenvalue, the eigenvector is second column, 1, 0, minus 1. Now again lambda is equal to 1. This is the third eigenvalue. The corresponding eigenvector is nothing but the third column in P. The third column is 2, minus 1, 0. Right? Now the first column represent the eigenvector of A corresponding to the eigenvalue 5. right? Similarly, the second column represents in P represents the eigenvector of A corresponding to eigenvalue of A. Now we got three eigenvectors now. Therefore, this one I am denoting by when. Now, no, you can write. Now, therefore, basis for eigenspace. Therefore, basis for eigenspace is nothing but, now you have to write these vectors 1 1 1. Here we wrote in vertical order, no, now you write horizontal order. This is 1 0 minus 1. Third one is what? 2 minus 1 0. Now these three vectors 1 2 3 vectors form an forms a basis for eigenspace. Now, what are the elements in the basis of a eigenspace? The elements are nothing but the columns in the P matrix, invertible matrix. And these are nothing but eigenvectors of A corresponding to the eigenvalue. Now we'll solve the same problem, right? Now here this entire procedure based on finding the eigenvalues, eigenvectors, basis for eigenspace, and also complex eigenvalues. Now see, I am taking the same matrix to find the eigenvalues and also eigenvectors. See, this is a given problem. From this problem I am copying now as it is. Now the eigenvectors, or you can say the basis, depends upon the procedure we followed, right? Now eigenvectors may be different, right? Means not unique. See, first of all, Hamida, now see, you are given one problem. Now these are the 3 5 10 are the characteristics or eigenvalues. Now I am solving this problem. The same procedure you can solve this one, right? So I have taken A is equal to 2 2 1 1 3 1 1 2 2, right? Concentrate. Now number of topics are going to covered in this problem. Now first of all, our aim is to find the characteristic roots or eigenvalues. See, eigenvalues, or you can say characteristic roots. For this what we have to do? A minus lambda I, A matrix minus lambda into unit matrix of same order I have to take 1 0 0 0 1 0 0 0 1. Now here I am not writing this matrix because now here what I'll get? Lambda 0 0 lambda 0 0 lambda. We are multiplying inside. Now if you subtract corresponding positions, 2 minus lambda, 2 minus 0, 1 minus 0, 1 minus 0, 3 minus lambda, and 1 minus 0, 1 minus 0, 2 minus 0, 2 minus lambda. On simplification, what I am getting here? 2 minus lambda, 2 1, 1 3 minus lambda, 1 1 2 2 minus lambda. This is what? A minus lambda I is equal to this one, this matrix, right? Therefore now you have to write step by steps, right? Don't skip the steps, right? Now to find the eigenvalues or to find the characteristic equation, the same procedure. To find the characteristic equation, a determinant of A minus lambda I is equal to 0 is the characteristic equation, right? If you equate the determinant of A minus lambda I to 0, the resultant equation, that simplified equation, is called characteristic equation. Remember, this is there in the unit 4, I think, right? Now here we are finding determinant of this one, no? 2 minus lambda 2 1, 1 3 minus lambda 1, 1 2 minus lambda is equal to 0. Now expand this determinant. Now 2 minus lambda into 3 minus lambda into 2 minus lambda and minus 2 into 1. Close. Next minus 2. This is a symbol, minus 2 you will get. This is a formula, right? Sir, there is no minus 1 kaadu. It's there in the formula. Now into, delete this row, 1 minus 1 into 2 minus lambda minus 1 into 1 close. Next plus 1 into delete the row and column, that is 1 into 2 minus 1 into 3 minus lambda. We have to simplify this one, please be careful. Determinant of a minus lambda, you know this one, no, is equal to 0. I am writing 2 minus lambda into, I am multiplying this one, 3 2s are 6 minus 3 lambda minus 2 lambda plus lambda square, sorry, minus this 2 into 2 is 2 minus 2 into 1 into 2 minus lambda is 2 minus lambda, 1 into 1 is minus 1 plus 1 into 1 into 2 is 2 minus 1 into 3 is 3, 1 into minus lambda is plus 3 lambda, right, sorry, plus lambda. Okay, now again 2 minus lambda into this one, I am simplifying, lambda square minus 5 lambda plus 6, right, sorry, this 3 2s are 6, 6 minus 2 is there, no, 6 minus 2 is 4 minus multiplying inside 4 lambda, why, sorry, again I am doing mistake. Now see, multiply these two inside, minus 2 into 2 is 4, minus 2 into minus lambda is plus 4 lambda, minus 2 into sorry madams, minus 2 into 2 is minus 4, minus 2 into lambda is 2 lambda, sorry, minus 2 into minus 1 is plus 2. Here also this is 1, no problem, this is 2 minus 1 is minus 1 plus lambda. Again we have to simplify this one. Once again I am copying the same thing, 2 minus lambda into lambda square minus lambda plus 4. Is that clear? Next minus 4 plus 2 lambda plus 2. Minus 4 plus 2 lambda plus 2. Next plus into, sorry, plus into this one, no, minus 1 plus lambda, that is minus 1 plus lambda. Again simplified, 2 lambda square minus 10 lambda plus 8 minus lambda cube plus 5 lambda square minus 4 lambda, here minus 4 plus 2 lambda plus 2 minus 1 plus lambda. See, I am first of all I am writing minus lambda cube 2 lambda square 5 lambda square plus 7 lambda square, right, minus 10 lambda minus 4 lambda minus 14 lambda minus 14 lambda plus 2 lambda minus 12 lambda plus lambda minus 11 lambda, right. This is 8 minus 4 is minus 4, minus 4 plus 2 is 6 minus 1 is plus 5 is equal to 0. This is characteristic equation. If you want, you can multiply it by minus sign, then you will get lambda cube minus 7 lambda square plus 11 lambda minus 5 is equal to 0. Therefore this is the characteristic equation, right. Now to find the characteristic roots or eigenvalues, what we have to do, because it is a cubic equation, it has 3 roots, right. Now see, I am taking the coefficients. First of all I am taking 1, right, lambda is equal to 1, 0, 1 plus 0 is 1, 1 into 1 is plus 1. If you add these two, what I am getting here, minus 6, right, 1 into minus 6 is minus 6. Now what I am getting here, plus 5, sure, 1 into plus 5 is plus 5. If you add these two, I am getting 0. Therefore this equation can be written as lambda is equal to 1, not lambda minus 1 into, this becomes lambda square into this one, right, lambda into minus 6 and minus 6 lambda plus constant. Now again lambda minus 1 into, you have to find the factors for this one. You can use minus b plus r minus b square minus 4ac by 2a, or you can factorize this one. Now what is the 4 2 3s are 6 into product is 5, no? Product is 5 means you have to find the product. 3 into 2, 3, no, you are not getting 6 here. Then what you have to do? Minus 5 into minus 1. Product is plus 5, right? Lambda square minus 5 lambda minus lambda plus 5 is equal to 0. Lambda minus 1 into, here you take lambda common, lambda minus 5 minus 1 common, lambda minus 5 is equal to 0. Lambda minus 1, here you will take lambda minus 5 common, lambda minus 1 is equal to 0. Lambda minus 1, lambda minus 5, lambda minus 1 is equal to 0. If you equate each factor to 0, you will get lambda is equal to 1 comma 1 comma 5. Therefore, characteristic roots, or you can say eigen values, are 1 comma 1 comma 5. See, for the same problem, previous problem only, no? Just I copied. Where is that? See, here in the previous problem expressed, see, the eigenvalues are nothing but the elements in the diagonal matrix 5 1 1 1. Here order is not important. Okay, now we know how to find the characteristic values or eigen values. Now the next topic, here this is page number, this, what I forgot, page number 1. This is page number 2 I am writing here. This is page number 3. Here this is page number 4. Now this one is very important. What is the next one? Eigen vectors. To find eigen vectors, find eigen vectors. To find eigen vectors, see, case 1, for lambda is equal to 1, case 1, corresponding to this eigenvalue, we have to find eigenvector. To find eigenvector, a minus lambda I into x is equal to 0. Substitute. What is A? A is a matrix. What is that matrix? 2 to 1, no? 2 to 1, 1 3 1, 1 2 2. Minus lambda is 1, no? 1 0 0 0 1 0 0 0 1. Whole thing into x is equal to 0. Now directly I am writing here, please. 2 minus 1 is, on simplification 1 into something is same thing, no? 2 minus 1 is 1, 2 1, 1, 3 minus 1 is 2, 1 minus 1 is 0, 1, 2 minus 2 is 2, 2 minus 1 is 1, right? Okay, this one into x is equal to 0. So what is x here? Eigenvectors 1 2 1, again 1 2 1, 1 2 1. I am getting, no? Here x means x1 x2 x3 is equal to 0 means 0 0 0. This step is very very important. Now we need to find x1 x2 x3, right? Now you have to multiply these two matrices, 1 into x1, 2 into x2, 1 into x3, right? Directly you can multiply and you will get 3 equations. Remember, here for any problem you will get 3 equations, right? Now instead of solving those 3 equations, it's a headache, right? Now first of all simplify this one and reduce the matrix into echelon form. That's it. Now it will be very easy. See, R2 changes to R2 minus R1. R3 changes to R3 minus R1. See, 1 2 1, 1 minus 1 0, 2 minus 2 0, 1 minus 1 0, 0 0 0 into x1 x2 x3 is equal to 0 0 0. Now it will be 0. Now multiply this one. How many equations you will get? 1 into x1 is x1 plus 2x2 plus x3, right? This is 0, this is 0 is equal to 0 0 0. Equate corresponding positions. What is the page number? 4 5, no, this one. Now what I am getting here, x1 plus 2x2 plus x3 is equal to 0. Now here x1 is equal to minus 2x2 minus x3. If you transpose the other things to right hand side, we are getting this one. See, there are other no equations. If you want, you can express x2 in terms of x1 x3. or you can express x3 in terms of x1 and x2. That is your wish, right? Now see here, these are independent variables, right? And this is a dependent variable. X1 is dependent on x2 and x3. Here I am choosing x2 is equal to 1, x3 is equal to 1. I am choosing like this. If you want, you can choose 2 comma 2, 2 comma 3, 4 comma 5, your wish, or k comma k. Now x1 is equal to what? Minus 2 into 1, minus 1. x1 is equal to minus 2 minus 1 is minus 3. Therefore, x is equal to x1, x2, x3 is equal to, right? Now like you can write like this. What is x1 value? Now we got minus 3. This one x2 is equal to chosen as 1, x3 is as 1. Therefore, this is an eigen vector corresponding to the eigenvalue 1. This is one procedure to find this one. Another procedure is directly write x1, x2, x3. This is, you remember this one. Now what is x1 here? Minus 2x2 minus x3. x2 we don't know, x2 is x2, x3 is x3. Now split this one. Here you can take x2 common, no? Please concentrate. x2 common. What I am getting here? Minus 2. In the next one, 1. In the next one, there is no x2, 0. Plus if you take x3 common from here, there are only two variables now. From the first one, minus 1. There is no x3, 0. x3 is there. Coefficient is 1. See? Now these are the minus 2, 1, 0, minus 1, 0, 1. Right? These are the eigenvectors, you can say. Right? Now what is basis for eigenspaces are? Basis means now we got this corresponding eigenvector corresponding to lambda is equal to 1, no? Right? And also you will get eigenvector corresponding to eigenvalue lambda is equal to 5, no? Right? See. Now that eigenvector and these two collection in row wise called basis for eigenspace. Remember, please try to solve another problem. Find eigenvectors and also find basis for eigenspace. Basis is nothing but collection of vectors. What vectors? Eigenvectors is called basis in row wise, right? The next one is complex eigenvalues. See, eigenvectors, linear transformation. In the next video I'll explain once again. See, complex eigenvalues. See, exercise I am taking here. What is that exercise? 1 minus 2 1 3. A is equal to 1 minus 2 1 3. Now find the eigenvectors. Same procedure. A minus lambda I 1 minus 2 1 3 minus lambda into 1 0 0 1. Right? Now A minus lambda I is equal to what you will get here? 1 minus lambda minus 2 1 3 minus lambda. Determinant of A minus lambda I 1 minus lambda minus 2 1 3 minus lambda. Now determinant you find out. 1 minus lambda into 3 minus lambda minus 1 into minus 2. Right? This is 1 into 3 is 3. 1 into minus lambda minus 3 lambda plus lambda square. This is plus 2. Now if you equate it to 0, you will get characteristic equation. Lambda square minus 4 lambda. This is plus 5 is equal to 0. Now whether you are getting here complex eigenvalues or not, I don't know. First of all, you have to find the factors. Now we can find the factors. 5 and 10. Now 5 into 1 is 5. This minus 4. Here we are getting the factors. See, lambda square minus 5 lambda plus 1. For lambda plus 5 is equal to 0. Here we are getting the factors or not? No, we are not getting the factors. See. Minus 5 into 1 is not equal to minus 5. So we are not getting the factors. In that case, we have to use minus b plus or minus b square minus 4ac by 2a. Minus b, minus of minus 4, plus or minus b square 16, minus 4 a1 c5 by 2 into a1. This is equal to plus 4 minus of minus plus 4 plus or minus 16 minus 20 by 2, which is equal to 4 plus or minus 14 minus 4 by 2. Right, here I am writing this one. Lambda is equal to minus 4 plus or minus 4 is under root, right? Now it can be written as 2 root I. If minus sign is there under root, then we have to write like this, because I square is equal to minus 1, square root of minus 1 is I. Now by 2, on simplification 2 to ante plus 4, no, here this is plus 4, okay. 2 plus or minus 2i. Therefore, lambda is equal to 2 plus 2i, comma 2 minus 2i. Now, these are complex numbers. Therefore, the eigenvalues are the complex eigenvalues. That's it. Now, how to find eigenvectors? Same procedure, right?